This is section 5.5, and now that we know what logarithms are, we're going to talk about properties of logs and ones that we will use in working on some of our problems. So they're in this chart, but I rewrote the important ones down here. The product rule or property says that if you have log base A of a product, here we've got m times n, you can separate that into two logs that are added. Bases are the same, but you're doing addition. So multiplication goes to addition. Likewise, if you have log base A of a quotient, it can be separated into two logs that are being subtracted. So that becomes important going either way, product to addition or addition to product, quotient to subtraction or subtraction to quotient. The last one that we use a lot is log base A of m to the r. That's the power rule, and it allows us to get the power to the front, kind of like in our rule that we had in the last section. So we want to remember the rule ln of e to the -4. That's just -4. ln of e to anything is the anything. So there's a couple of those. So let's look at how these properties work. We've got several examples here. So log base 8 of 2 plus log base 8 of 4, you're supposed to evaluate that, write it as a single log, and then if you can, evaluate. So that's an addition, so it becomes a product. Log base 8 of 2 times 4. Log base 8 of 8. It's one of the properties that I didn't mention, but if you have, let's see, I thought I had it up here, but log base A of A equals 1. Okay, log base A of A, that doesn't really work for it. Yes, log base A of A equals 1 because 8 to what power gives me 8? That'd be the first power. So log base 8 of 8 is 1. This is a subtraction, so we know that we can write it as a single log that's a quotient. Log base 6 of 18 over 3, we end up with log base 6 of 6, we still get a 1. All right. This one throws people all the time, and it's so easy. Log base 3 of 3 to the 71. What does that equal? Well, if you write it as an exponential thing, 3 to what power gives me the argument that is 3 to the 71? And then you can see this question mark has to be 71. Okay. Change of base formula, use that for log base 4 of 26. Remember, that's the formula. You can go to math and then up to log base, or you can use the change of base formula, which I have right there, depending on your calculator. And so you just do that one in the calculator. This is an addition. Log base 6 of 9 times 4, log base 6 of 36. 6 to what power gives me 36? That's 2. All right, write as a single log. So now we're going backwards. We've got an addition. We know that can be written as a multiplication, but the first thing we want to do is to move our powers back here. So if you see powers in the front, you can move them. That's what happened here. And then I'm going to write it as a product. Log base 5, u cubed v to the 4th. This example, we're doing subtraction. So we're going to put this 5 up here as a power. So now I've got 2 log base 4s, and I'm going to write it, because it's subtraction, I'm going to write it as a quotient. But since I know that x squared minus 1 factors to this, x plus 1, x minus 1, and this is x plus 1 to the 5th, that can cancel out, and this becomes now x plus 1 to the 4th. So our final answer would look like that. Okay, let's go here. Log base A of 7 plus 4 log base A of 3. Again, bring the 4 to the top, so there's a power there. Let's go ahead and make that 3 to the 4th is 81. So now that looks pretty simple. log base A of 7 times 81, and we will write it as log base A of that product, which is 567. So I think that's all the examples. Let's go look at the problem set. So this is a short section as far as problems. There's only 10. Let's see what we get. Log base A of A to the R. Remember what we said? A to what power gives me A to the R? Well, that's got to be R. Complete the sentence below. You've got a product. You're going to switch it to an addition. It becomes log base A of M plus log base A of N. Log base A of a quotient becomes a subtraction, and we have log base A of M minus log base A of N. So you're choosing those. Number 4, ln of e to the 19th. Remember, ln of e to anything is the anything, so 19 goes there. Number 5, log base 6 of 3 plus log base 6 of 2. Well, remember, we're going to multiply to make it one log. So we have log base 6 of 3 times 2. That's log base 6 of 6. That equals 1. Number 6, we're going to put the powers up front as exponents. So that's my first step. Move the 5, move the 9. And then this is an addition. So as one log, it'll be a product. So we have log base 3 of u to the 5th times v to the 9th. Number 7, this is a subtraction. We're supposed to write it as a single log. So log base 4 of this minus, what did I do here? I put that 6 to the power. Now I can write it as a quotient, x squared minus 9 over x plus 3 to the 6th. Remember, we're going to factor that top because we know there's an x plus 3 in there. So x minus 3, x plus 3 over x plus 3 to the 6th. That one can cancel out and we lose one of these. So now we have log base 4 of x minus 3 over x plus 3 to the 5th. Use common logs or natural logs to do this. And I just put the calculator screen. You could do log. You can go and do math log base. And then when you get the icon, you're putting 17 in the bottom, 18 there, and you get, and it says round to 4 decimal places. So this 1 here becomes a 2 because the 7 to the right of it, you round up. 9, we're doing the same thing. Log base 1/3 of 4. Do that in your calculator. You'll get this. Round to 3 decimal places. It changes often, so read your directions. Change of base formula. It wants you to write it here. So this is log of square root of 19 divided by log of pi. Then you do it on your calculator and you get that. It says round to 3 places. So that covers the problems for section 5.5.